Okay, this is Catastrophe problem 2.17. This is a lot harder than it actually looks if we can think about some vectors here. So we have another building that we're going to be shooting cats off of, and this building is 210 meters tall, and there's a cat that is thrown down at 25 meters per second. And there's another cat down here that's thrown up at 25 meters per second, and then a cat obviously could fall back down to the ground. So the question is, how far from the ground, how far up from the ground will there be a cat fight? Which means, I'm telling you in the problem that there is going to be a cat fight, so the cats can collide. So this cat's going to be falling all the way down here. The thing is, we don't really know if the cat hits this cat on the way up or on the way down, because it could come up and then start going back down again. This cat could catch up to it and hit it, or it could be hitting it on the way up. We don't really know. But what we're going to do is we're going to try to figure out the distance from the ground that the cat hits. And so the time from their launches would be the same also. So we're going to use D equals VIT plus 1/2 AT squared, and we're going to figure out the displacement from the ground for both cats at the place of contact, and then we should be able to set those together, solve for T, and then plug it back in. So hopefully you'll understand kind of what's happening here. So let's look at the cat here on the ground first, because that'll make the most sense. So how far up from the ground is the cat when he hits it? Well, D is going to be the distance that he's going to hit it at. Initial velocity is 25. We don't know the time. Plus 1/2 A, which is gravity, 1/2 negative 9.81 times T squared. Okay, so that doesn't seem like it helps us a whole lot. This is the distance here that we're trying to solve for, but we still don't know the time. So if we can do another equation for this displacement, and we look at the other cat, but we're still going to measure from our frame of reference. That's important. We're not actually measuring the displacement of this cat down to here. We're going to measure the displacement of this cat from up here, and even though this cat then has technically an initial displacement of way up here. And in this equation here, this is the way we kind of always write this equation, but technically this is a quadratic, and there's always a plus initial displacement. The thing is, in almost every problem we do, we're measuring from where we're starting, and so initial displacement is always 0 usually. But in this problem, we're trying to measure from the ground up. So if we're going to describe this cat that's already up here at the top, we have an initial displacement of that cat being far away. So D in this case would be the initial velocity is downward, so it's a negative 25 T plus 1/2 negative 9.81, gravity's still down, T squared, and then we'd have a plus initial displacement from the ground. That'd be 210 meters up. 210 meters up. Now we know that these displacements are going to be from here to there. So these displacements here are equal. They're both this displacement right here. So I can set them to be equal and then solve for the time. So if I have a negative 25t here and a plus 25t on the other side, if I take it over to the other side, that's going to be a 50t. And this term and this term actually go completely away. So 50t equals 210, and t equals 4.2 seconds. And then all I got to do to figure out the displacement from here up to here would be to take this 4.2 seconds, plug it back into this equation, in for the time, obviously, and solve for the displacement. And when I do that, I put that back in there, you should solve this, I get a displacement of 18.5 meters up from the ground. 18.5 meters up from the ground. Now, as a kind of a follow-up here, I'm curious, did this cat get hit on the way up or on the way down? And there's a couple ways we could figure that out. We could figure out how much time it took to go all the way up here to the top. That'd be pretty easy, because VF at the top, we could use VF equals AT plus VI, and VF up here at the top would be 0 equals a negative 9.81 times our time, which we know is, well, we don't know our time. We're trying to figure out a time to get all the way up here to the top. Plus initial velocity is 25. Take the 25 over to the other side. Take negative 25 divided by negative 9.81, and I would get a time of 2.5 seconds to get up here to the top. Well, we know they're hit at 4.2 seconds, so clearly there's one way of telling that we're on the way down when this cat fight happens. The other way would just have been able to figure out what the final velocity is, and see if it's negative or positive. So I could have just done final velocity equals negative 9.81 times the time is at 4.2 seconds, plus the initial velocity down here at the bottom for this cat is 25. And I could solve for a final velocity, and if I do that, I get a negative 16.2 meters per second. That's another way of knowing that it's actually on the way down because it's a negative velocity. So this cat has to be going back down when the cat fight began. So QED on that, and hopefully that helps you solve all your problems in your physics book.